Welcome to this explainer. Okay, today we are going to challenge a narrative that honestly, most of us just accept as absolute fact. We're exploring science's global roots. You see, when we picture the scientific revolution, we usually imagine a very specific time and a very specific place. But what if that's really only half the story? So, where did the scientific revolution actually begin? We've all sat in those standard history classes learning all about the great European awakenings of the 16th and 17th centuries. But as we'll see, there is a whole other timeline of incredible, truly mind-bending discovery that happened far earlier in a completely different part of the world. We typically celebrate Western milestones, right? Figures like Newton and Copernicus in the 1500s and 1600s. But centuries earlier, ancient Indian scholars like Aryabhata and the brilliant minds at the Kerala school were already hitting massive scientific milestones. Think about this. While parts of Europe were still fiercely debating basic geocentric models and the very shape of the cosmos, ancient Indian civilization was already calculating the distances between the Earth, Sun, and Moon with just astonishing mathematical precision.
Section 1. Cosmic Calculations. Reaching for the Stars.
A really pivotal classical text in this era was the Aryabhatiya, written around 499 CE by the mathematician and astronomer Aryabhata. And here's the kicker. Instead of relying on optical magnification, which obviously didn't exist yet, these Indian astronomers used naked eye observations aided by high-precision physical instruments. They were literally mapping the cosmos using incredibly sophisticated mathematical and trigonometric systems. To really understand just how accurate they were, listen to this calculation. 23 hours, 56 minutes, and 4.1 seconds. That was Aryabhata's measurement for the Earth's sidereal rotation. Now, the modern, highly technology-driven measurement we use today, it's 23 hours, 56 minutes, and 4.09 seconds. His calculation from over 1,500 years ago is off by less than 1/100th of a second. It is absolutely staggering. And he didn't just measure the Earth. He intuitively understood how it moved in space. Aryabhata used this brilliant analogy. He said, just as someone in a moving boat sees stationary objects on the bank moving backward, an observer sees the fixed stars moving westward. He recognized that the Earth is actually spinning on its axis, which creates the illusion of a moving sky. This advanced understanding extended directly into physics, too. Over a millennium before Isaac Newton formulated his laws of motion, Indian scholars were already describing a binding, attractive force. In 628 CE, Brahmagupta explicitly wrote that bodies fall toward the Earth because it is the very nature of the Earth to attract them. The conceptual groundwork for gravity, it was already firmly established. Section 2. Pioneers of Empirical Surgery. This brings us to a fascinating document called the Sushruta Samhita, dating all the way back to roughly 600 BCE. While many parts of the world were still heavily relying on supernatural explanations for illness and healing, Sushruta pioneered a highly systematic, empirical surgical tradition. This text effectively laid the foundational groundwork for modern plastic surgery. Just consider the steps for a reconstructive rhinoplasty outlined in these ancient texts. The surgeon would literally measure the defect with a creeper leaf, harvest a living flesh flap from the cheek, suture it perfectly into place, insert hollow tubes made from castor oil plants to keep the airways open, and then treat the wound with ghee and honey to promote healing. I mean, this proves just how remarkably methodical and sophisticated ancient Indian medicine truly was. Section 3. The Transmission of Calculus. Okay, so starting around 1300 CE, the Kerala School of Mathematics and Astronomy began making massive discoveries, essentially developing infinite series and the absolute foundations of calculus. And this is up to 300 years before Newton and Leibniz are credited with inventing it in Europe. Then, in the 16th century, European Jesuit missionaries arrived in India, actively seeking out local texts and knowledge. This brings up a highly debated but super fascinating academic analysis. Did calculus actually migrate from the Kerala school to Europe? Documentary evidence clearly suggests that European scholars and missionaries were actively collecting these highly advanced mathematical texts. Scholars actually frame this using a legal standard of proof. First, you have motivation. Europe desperately needed better mathematics for navigation and calendar reform. Second, opportunity. Jesuit missionaries were physically there, translating and collecting local scientific texts. And finally, circumstantial evidence. Shortly after these texts were collected, remarkably similar mathematical methods suddenly began appearing in Europe. It's a very compelling case that foundational mathematical knowledge migrated straight from east to west. Section 4. colonialism and historical erasure. To really ground the reality of this colonial impact, we can look at primary sources from outsiders who witnessed it firsthand. In 1929, the famous quantum physicist Werner Heisenberg wrote a very revealing letter while traveling in Darjeeling, India. In his letter, Heisenberg impartially observes the severe economic drain happening under British rule. He writes, "Obviously, all profits are pocketed by the English, do not stay in the country, and can therefore not be used for infrastructure improvements." To put Heisenberg's observation into perspective, economic historians note that prior to colonization, India represented roughly 25% of the world's GDP. By the time the British left, it was down to around 5%, with some modern economic analyses estimating that nearly $45 trillion in wealth was extracted. This profoundly drained the region's resources and knowledge. But as these sources point out, colonization wasn't just about economic wealth, right? It involved a deep intellectual appropriation. The narrative was actively shifted, historical chronologies were altered, non-European achievements were minimized, and earlier Indian discoveries were frequently whitewashed and simply claimed as European inventions, or explained away as being derived from Greek models. This Eurocentric rewriting essentially scrubbed these foundational Indian contributions right out of mainstream academic histories. Section 5. Synthesis, Cosmology and Quantum Physics. Now, thousands of years ago, ancient Indian texts were already describing a highly complex, multidimensional reality. They explored kalpas, this concept of an infinite cyclical universe, with innumerable universes existing simultaneously. For centuries, the West operated on a strictly linear timeline of the universe. But today, the absolute cutting edge of modern astrophysics has basically caught up to the ancients, seriously researching theories like the multiverse and cyclic models of the universe. And you know what? The pioneers of modern science absolutely knew this. Nobel laureate Erwin Schrödinger, literally one of the founding fathers of quantum mechanics, frequently referred to the ancient Upanishads to help him conceptualize the bizarre and profound realities of particle physics and consciousness. They didn't see these texts as mere mythology. They saw them as high-level scientific and philosophical hypotheses, which leaves us with a profound paradigm shift. So what does this all mean? How does our understanding of the universe and of human potential change when we view science not strictly as a Western invention, but as a shared global heritage? When we realize the sheer depth of knowledge that existed thousands of years ago, it completely rewrites the story of human progress. Thanks for joining me on this explainer, and keep questioning the history you've been taught.